Hello, so now we're going to do the slightly more complicated version of what we did in our last video. So if we started like we did before, we work out the first difference, which is 6, 8, 10, and 12. Now we can tell that because these numbers are different, it's obviously not a linear sequence. So now we try our second difference, which is 2, 2, and 2. So this tells us this must be quadratic because there is a constant second difference. Now to work out how many n squareds we've got, we halve the constant second difference, which equals 1. So now if we go on to here, we got our 1n squared. Now if we work out this for the n's, we've got 1, 4, 9, 16 and 25. So now if we work out the difference between this, we've got 8, 11, 14, slightly more tricky one here, 17 and 20. So we could tell straight away that this is another linear sequence. This is where it gets slightly more complicated than it did last time. So now if we treat this like a normal linear sequence, we work out the first difference, which is 3, 3, 3, 3. So this confirms my suspicion, so it's a linear sequence because the first difference is constant. So now if we use our dyno method, which is difference n and 0th term, we get the difference, which is obviously 3, and we put the n, and then if we had a 0th term on this sequence, it would be 8 take away 3, which is 5, so 3n plus 5. Now if we add this onto what we originally had, it would be n squared plus 3n plus 5. Now this is what we've got. So now if we double check this, we've got 3n plus 3 squared, sorry, n squared plus 3n plus 5. So now if we check this, we could do it with 1 plus 3 plus 5 equals 9, which is what we got in the original sequence. Try it with 2. We've got 2 squared, which is 4, plus 3 times 2, which is 6, plus 5, and that equals 15, which is what we got in our original sequence. And if we do it one last time with 3 squared is 9. And if we add that to 3 times 3, which is 9, plus 5, which then equals 23. And this is what we got in our sequence. So you now know that this is the right quadratic sequence. So that's how to work out the quadratic sequence. So yeah, thanks a lot. Enjoy.